go. Thank you. So we want to find the exact value. We're going to look at what's inside the parentheses first. We're going to concentrate on this tangent inverse of 5 over 12. Okay? And let's understand what we're looking at here. What's the domain for the tangent inverse of theta? You guys remember from Thursday? Go ahead. Okay. All right. Any real number. Now, what's the domain of the cosine? Also, any real number, right? But when we were looking at the inverse tangent, what did we restrict our range to? Let's look at everything that we got for inverse tangent. The domain goes from negative infinity to infinity, but what about the range? Negative pi over 2 to pi over 2, okay? Which means that the answer that I'm going to get for the inverse tangent of 12 over whatever it was is going to be between negative pi over 2 and pi over 2, right? That's what I'm looking for. Now, so the domain for this thing is going to be negative infinity to infinity. And then the range is going to be from negative pi over 2 to pi over 2. So the tangent inverse of 5 over 12 will be between negative pi over 2 and pi over 2, okay, as far as finding the theta, okay? Now, let's think about this. What is theta when the tangent equals 5 over 12? That's a question that we need to be thinking about. And if we look at that, let's think about what's going on. Because if I've got tangent theta is equal to 5 over 12, I know that this is going to be the opposite over the adjacent, right, in right triangle trigonometry. And if I go ahead and throw down an xy coordinate system, what quadrant angle am I looking at for 5 over 12? Jesse? It's first quadrant, right? Why is it first quadrant, Sydney? Because both of them are positive. Because both 5 and both 12 are positive. Okay? So that means I know that I've got a first quadrant angle going on here. So theta's in the first quadrant, and I can go ahead and put some point up here. And I know that the point itself is going to be 12 comma 5. Why is it going to be 12 comma 5? Because opposite is going to be my y, adjacent is going to be my x. And if I draw a right triangle, I know that this side is 5 and this side is 12, which means that I can easily figure out what the hypotenuse is. Okay. Okay. Say what? I can't hear you. Yeah, you're going to use the Pythagorean Theorem, right? But we should already know what that hypotenuse is. Because if you're familiar with Pythagorean triples, you already know. What's the most common Pythagorean triple that we have? Go ahead. 3, 4, 5. This is the next most common Pythagorean triple. Caitlin, what is it? Thank you. Guys, speak up. 5, 12, 13. Since this is a Pythagorean triple, I know this is going to be 13. Why do I care? Well, the reason that I care is because I'm looking at finding the cosine of the inverse tangent of 5 over 12. And I know that the inverse tangent of 5 over 12 is going to be equal to some theta. So that means I'm looking at cosine of theta, correct? It happens to be this particular theta. That's why I care, because what is cosine? Adjacent over hypotenuse, or x over r, or however you want to define it. Okay? So this setup, this right triangle trigonometry here, also, and that's a really bad semicircle, but just pretend, okay? It's also a circle that has a radius of what? 13. So now that I know this, the cosine of theta, if theta is equal to 5, 12, 13, is going to be equal to what? 12 over 13. Which means that the cosine of the inverse tangent of 5 over 12 is equal to 12 over 13. At no point did I need to know what theta was. Okay? And if you can't remember that it's a Pythagorean triple, what are you going to do? Use the Pythagorean theorem. Now, all of these that you're going to have to do without the benefit of a calculator, obviously the legs and the hypotenuse will form a Pythagorean triple. Because I'm not expecting you to be able to find the square root of something. Well, actually you could. All right, what's the square root of 225? What? 15. You guys can do that off the top of your head. What's the square root of 265? Say what? Yeah. What is the square root of 265? That is a really good question, is it not? Let's think about that for a moment. Just consider the square root of 265. Are there any perfect squares that are factors of 265? Jesse?
It's a factor of 5.
So we do 5 goes into 265, right? That's 5 times 5 is 25. That's 15, and that's 3. No. So what is the square root of 265? The square root of 265, right? Okay. So even if it's not a Pythagorean triple, you can leave it in terms of the square root, correct? Some of you guys are not looking happy right now. Why? Come on, you guys can do this. Let's do one that involves something that's a little less easy than the one that we just did. Using the fact that, now this one's easy because it's a Pythagorean triple. We can throw this one down pretty quick. Okay, I'm looking, and we'll do this one, then we'll do the one that's not a Pythagorean triple. So I'm looking for the sine of theta, where theta is equal to the inverse tangent of 3 over 4, which means that y is equal to 3 and x is equal to 4. What quadrant am I looking at? First quadrant. So this right here is going to be 3. This right here is going to be 4, and obviously that's going to be 5. My theta is right here. This is going to be my opposite. This is my adjacent. You want to call it y. You want to call it x. I don't really care. That should be a big A. Sorry. The sine of theta is what? The sine of theta is equal to opposite over hypotenuse. So in this case, opposite is 3, hypotenuse is 5, and I'm done. That's it. That's how easy these things are. You don't need a calculator. In fact, it took me probably less time to do it in my head without a calculator than it would take me to punch all of that into a calculator. Now let's look at this one. We want to consider the cotangent of the inverse sine of negative 1/3. Which means that this right here is going to be my theta. So I'm looking to find the cotangent of theta where theta is equal to the inverse sine of negative 1/3. So what do I do here? Okay. What is this telling me to do? It's telling me to find a theta such that the sine of theta is equal to negative 1/3. That's really what I'm looking for. Now, let's talk about this. What do I know about theta when I'm dealing with inverse sine? It's going to fall between negative pi over 2 and pi over 2, right? If the sine of theta is a negative 1/3, what quadrant is it in? Okay, who said that over there? Somebody said fourth. It's a fourth quadrant angle. Why do I know that? Because the denominator in sine always has to be what? Positive, because it's the hypotenuse. It's the radius. It will always be a positive value. Therefore, it's the numerator that's going to be negative. That means it's opposite. Sine is negative where? In the third and fourth quadrant. Obviously, I can't deal with the third quadrant because it falls outside of negative pi over 2 to pi over 2. So we're dealing with a fourth quadrant angle here. Now, if I have a fourth quadrant angle, it's some theta. I'm going to have some x comma y. That is a sine function. The sine of theta is negative 1/3. The 3 is going to be what? The hypotenuse. And this negative 1 is going to be the y value. So I'm going to put negative 1 right here. I'm going to put 3 right there. I know that the y is negative 1, so what am I missing? I'm missing the x. That is not part of a Pythagorean triple, so I'm going to have to use the Pythagorean theorem to figure it out. Remember that r is, let's not do it like that. Let's do it like this. X squared plus y squared is equal to r squared. I know what y is, it's negative 1. I know what r is. X squared plus negative 1 quantity squared is equal to 3 squared. So x squared plus 1 equals 9. X squared is equal to 8. X is equal to plus or minus the square root of 8. Is it going to be a positive or a negative value? Positive, because x is positive in the fourth quadrant. So therefore, x is equal to the square root of 8. But what is the square root of 8? It's 2 square root of 2. I didn't need a calculator, did I? That's going to be my adjacent. And what was I looking to find? The cotangent of theta. What's the cotangent? Well, cotangent of theta is equal to adjacent over opposite, which in this case is what? 2 square root of 2 over negative 1. So simply negative 2 square root of 2. At no point did my fingers touch the keyboard of a calculator. We don't need no stinking calculators. Okay? Any questions on this? Just remember your algebra. Yeah, Unit circle, right triangle, trigonometry, using it all together.
So that point would be
Yeah, that point would be on a circle that has radius 3. Unit circle has radius of 1. However, the theta wouldn't change. Okay, does that make sense? Yes, Jesse.
what is the time limit on
1 hour, 15 minutes. Now, inside my math lab, there's a practice quiz or test for Unit 1, Section 4.1 through 4.8, and it's got a boatload of problems in it. How many was it, Troy? There should be.